Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Then we would start right away. Let me just turn on my preview screen to confirm. Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Then we would start right away. Let me just turn on my preview screen to confirm. Okay, so let's start. Today we would be doing yesterday's problem of the day, that is maximum winning score. This problem appeared in Morgan Stanley and this has a success percentage of 84% and this is a medium level problem. Thanks a lot Aditya. Okay, so let us read and understand the problem statement. In an online game, there are n blocks that are arranged in hierarchical manner. Hierarchical manner, you can resemble it with the family tree. They all have relations between them. All the blocks are connected by a total of n minus 1 connections. So hierarchical manner represents, okay, or rather gives us an indication that this is a graph problem or either a tree problem. Moving forward, when we see that there is n minus 1 connection, we can say that this is a tree problem. Okay, fair enough. So each block has been given an ID from 1 to n. Okay, this further confirms the fact that yes, this is a tree where it starts from 1 till the n. Okay, and the block may be further connected to other block. Each block is assigned a specific point value. So there is also a value associated with the ID. Okay, so player would start from block 1. You can say that the player would start from the root. Okay, so C must move forward in each block to a directly connected block. So suppose there is a connection like this. Okay, so this can only move to this. This is not possible, but this can move to this block. Okay, they are directly connected. Now there is one more thing that tells us. Okay, suppose this thing. Okay, suppose this can be the tree. Now from this block I can move to this block and this block, but not this block. Okay, now it is said that to a direct which has no further connections. Until C reaches no further connection, it boils down to the fact that it is telling that until we reach the leaf node. Okay, you can kind of try to resemble it. Okay, now moving forward, when the player lands on a block, she collects the point value. So basically whenever I go to that block, visit that block, I would add that value. Okay, now the value is calculated by the product of the point number. So suppose the points were like this. Okay, and it is a kind of skew tree and the points associated are 1, 2, 1, 2 and 3. The values would be 1 multiplied with 2 and multiplied with 3. That is nothing but 6. Okay, and you need to find the maximum score the player can achieve. Okay, so in the first view we can say that if we come across this, we would first take out the point value where we are standing, we would collect that. Moving forward, we would go to either 2 or either 8. We have two options. So we would select the larger one. Then we again have two options, 3 and 4, because larger value would make larger product. So we would go to this value and 8 into 4 into 4 is equals to 128. So it seems simple. What we can do is we can visit the root node. Then we would have the values of left and right. Okay, whichever is greater we would move in that direction. In the first place, this question seems to be this, but the problem would occur when the connections would be like this. Suppose it is 4, then there is 100 and here it is 1, and then there is 1000 and then there is 2. So the value would be, according to us, last thing we thought of would be this value, because this value is greater, we went to this value. Okay, but in reality the value would be the multiplication of these all terms. Okay, so we can say that moving towards the maximum side won't be the correct answer always. It might be for this case, that sample test case it is given. but it can't be always. So what we can do is, if we can't decide on moving greedily, we can think of all possible ways. Whenever we think about all possible ways, we should think about recursion. Okay, recursion we would think about in all possible ways. And if that is a DP problem, we would further memorize it and we would say that yes, the problem boils down to the DP problem. But here we won't be going in that direction, rather we would be just observing it. Okay, so we need to move on all the direction, and whatever is the maximum value, we need to do that. So what we can do is, we can give this thing and then we can move this side also and this side also. Whatever the value we are getting, we can take the maximum out of it. Okay, now let us first implement this, then we would talk about how this is working. Okay, so let me just do this. Yeah, so let us first think about the base case. Talking about the base case, so if I just maximize it a bit, so yeah, this is further maximized and this is great. Okay, so what we can do is, if we think about base case, whenever we reach the end, we need to return the value. Okay, so whenever we are reaching the end, we are returning the value. So what can be the base case? The base case, if we do 0, then suppose till that point, till we are reaching that point, it is 100, and that value would be destroyed by multiplying it with 0. So what we can do is, if the root equals to null, we can multiply it with 1 because it won't affect the answer. Okay, return 1. Then we would have two values. Okay, and that value would be long. Why? Because we need to return long, and it is said that it can fit in a 64-bit integer, not 32. So instead of int, we are taking long. So long v1 is equals to, or we can say that left side is equals to the current value root dash, okay, just let me see data, yeah, root that data multiplied with the find max score of root dash, okay, root dash left. Okay, we would move to the left hand side, then we come down and then we would copy the same thing. Okay, and we would here write RT. Okay, and in this side we would move to the right hand side. So we are moving on both the directions, and what we would do is we would return the maximum of RT or LF. Okay, so let us first compile and run. It might be the case that I would be making some errors as usual. So let me see. Yes, it is coming correct. So let us just submit it and see. Yes, we are able to pass this. Okay, so now let us talk about how this is all working. Okay, so to get to how this is all working, let us just see. Okay, so let us first give us a tree. Okay, suppose we have 3, we have 1, and here we have 2. The answer to this is 6. So let us see how this is working. First, we are giving it the value 3. 3 is not a null node. So what we would do is v1 would be equal to 3 multiplied by the function of right. Okay, so right side is 2. And this one v2 would be 3 multiplied by function of 1. Okay, then let's calculate the value of function of 2. So function of 2, it is not null, we would move forward. Okay, and it would be 2 multiplied with the value null. So null is 0, null is nothing, so we would multiply it with 1, and this would return me the value 2. Now this is f1, we would go, and f1 would be 1 multiplied with the value null, that is 1 itself. That would be 1 itself. So that is nothing but fx of 1 would be 1. So that is 3 multiplied with 2 is equals to 6, and this would be 3 multiplied with 1 is equals to 3. So we are taking hold of both the values, whatever values we are getting. So this is just checking all the possible values. Okay, fair enough. This is how we are just taking out the max out of it and we are returning it. I hope this is clear. Still, I would wait for the next 1 minute to see if there is any further doubts or not. If there is no further doubts, I would just turn off the session. So I would wait for the next 1 minute. This is an open forum now. You can quickly ask your doubts. Please like the video. Okay. What will be the time complexity of this approach? So basically what we are doing is we are visiting all the nodes and we are not revisiting it. That would be just the number of nodes. Okay, this is the time complexity, that is big O of n, the number of nodes. And this comparison is nothing but a constant operation, so we would ignore that, and this is it. I hope this is clear. Thank you and have a nice day. Meet you tomorrow.